So, good morning, students. And last class, we have been dealing with your DFT. So, the basics of DFT we have been dealing. The comparison between DFT and DTFT we have been. So, in today's class and in last class also, we have also dealt with some basic examples. And in today's class, we'll be dealing with respect to your some other problems. We'll be getting deeper into the problems. Okay. So starting with yeah, we'll be getting into it. Starting with this is the example number three, I think. Yeah, three it is. So here you can see given. So given they are giving a signal. So the signal is x of n. X of n is equal to u of n minus u of n minus six. U of n minus six. Okay. So what they are asking to find is to find to find asking to find Z transform. Okay, first one Z transform of x of n. Okay, Z transform of x of n they are asking to find. Okay, and sample it at sample it at 4 points. So 4 points. So as I have said, the main difference between DTFT and DFT is that in the DTFT you will be finding the Z transform along the unit circle, but in terms of your DFT, you will be sampling with an equal number of samples. So here they are giving the equal number of sample points as 4 points. They are giving it as 4 points. So on unit circle with relation. So they are giving out a relation with relation. So the relation is that capital X of k is equal to capital X of z at z is equal to, so they are giving the z value, that this value z equal to e power j 2 pi 2 pi by n into k. Okay, so here the k value will be the same thing. They are giving 4 points, right? So k will be taking 0 to n minus 1 to 0 comma 1 comma 2 comma 3. So it is in the question itself. In the question itself, they will be giving this. Okay. So second, what they are giving, find inverse. You have to find inverse DFT of x of k. So you are finding the value of this, that is DFT you are finding, and you have to again find the IDFT. IDFT for this you are finding. Okay. After that, you have to compare with your this previous signal x of n, and compare with x of n. Okay, and comment, and you have to comment it. Okay, that is you have to do the thing. So we'll be getting into the solution directly. So okay, solution. So first what you have to do is you have to find the Z transform. Okay, the signal is given, so you have to find the Z transform, and then after that you have to sample it for equal time period. Okay, then you will be getting this example. Okay, so this is the Z transform, the value of the Z transform which you have taken from this signal. Okay, so what they are asking to find is you have to take the Z transform for this, and then you have to apply the sampled values over the found out Z transform. Okay, and then again you have to take the IDFT, that's the inverse DFT you have to take, and after taking the inverse DFT you have to compare with this signal and you have to comment. This is our objective. Okay, this is our objective of this problem. So starting with, so for this you have to get clear idea about your signal. Yeah, so that is okay. Let's start it. So x of n they are giving is equal to u of n minus of u of n minus. This is the signal. So this signal is sampled. Okay. So over this, the signal is given as, it is the unit base. So it is given for a 6 time. So we can just make the signal as either 1 comma 1 comma 1 comma 1. Okay. So it is the unit one. So it is 1 comma. So this belongs to 0. 0 to space. Okay. So it is the starting 1 comma 1 comma 1 comma. So this signal can be represented in this manner. Okay. So you'll be getting 0, and this will be your 1, this will be your 2, and this will be your 3. So it is in the unit circle, so it takes the value of 1. It is your 4, and this is your 5, and again another one will be there. So it is your 6th value. So this you can, how you can write it as x of n. This value of x of n you can write it as x of n yeah x of n is equal to this 1 comma 1 comma 1. So 6 times of 1. So this one you can write it as in this manner. Del of, it is during the 0th time it is 1. So it is del of n comma, next is sorry not comma, plus. This signal can be represented like this also. Del of n minus 1 plus del of n minus 2 up to your n minus 5 you will be getting n minus 2 plus del of n minus 3 plus del of n minus 4 plus del of n minus 5. Okay. So you have got the value. So this is a signal. For this x of n, what you have to do is you have to take your z transform. So you have to take your z transform and then apply the value of your z. Okay. So first you take z transform. This is step 2. Take z transform. Okay. Now what it happens? So you know to take z transform of this x of z is equal to this is z1, so it is 1 plus z power minus 1 plus z power minus 2 plus z power minus 3 plus z power minus 4 plus z power minus 5. Okay, so this is how it looks like. Okay, so now the next step. So we have found the z transform. Now we have to apply the value of z over here. So you know that the given is x of k equal to x of z over z equal to e power j into 2 pi by n into k. Okay. So now you want to know the n value. So n equal to 4 given in the question. Okay. So they have set it for 4 points on unit circle. So it is n equal to 4. So apply this, and over here k takes the value 0, 1, 2, and 3. So apply these values over here. We will getting x of k will be equal to x of z over z equal to e power j 2 pi by 4. Okay, here you can have the k value. The k you have to substitute 0, 1, 2, and 3. So now you substitute the value of k over here. We will be getting, so for this value, if you are substituting with k, so it is 1. For the first term, it is 1. So for the second time, instead of z, you put over this e value. So we'll be getting e power minus j 2 pi by 4. Okay. 2 pi by 4. The first one is 0. E power 0, it is 1. The next one, e power 1 into 1. Okay. So next one, e power minus 2j, okay, 2 pi by 4 into, so k value it is 2, so we have put over here 2. Okay. So next one plus e power minus 3j, okay, into 2 pi by 4. Okay. Next it is plus e power minus 4j to 2 pi by 4. Then again it is plus e power minus 5j just 2 pi by 4. So now you just cancel it out and you'll be getting the value as 1 plus 1 plus e power minus j 5 by 2 to k plus e power minus j pi k plus e power minus j 3 pi by 2 into k plus e power minus j 2 pi into k plus e power minus j pi 5 by 2 into k. This is the value. So on simplification of this, you'll be getting, there will be getting x of k as equal to, x of k will be equal to, be getting around 2 plus 2 plus 2 e power minus j into 5 by 2 5 by 2 k plus e power minus j 5 k, okay, plus e power minus j 3 pi by 2 into k. So here the k value should be coming out. So I will write the k value. So just write the k value, k, k. Okay. So now you got this. And next step is you have to take your IDFT. IDFT is the thing with a simple form. So it is pi by 2, right? So the time period is same. We will be getting take IDFT. Take IDFT of x of k. We will be getting x dash of n, which is the dash of n. So the same thing, we just omit these values. So we have the same value, 2 comma 2 comma. So it is the coefficient. So take the coefficient 1 comma. Here also it is 1. Okay. So we got x dash of n also we have got. So now we have to comment it. So we can put inference. So what we can inference from these two figures, x of n and x dash of n, is that by comparing time domain aliases occurs in first 2 points, first 2 points, because of that not sample. With sufficient number of points on unit surface. So this is the true factor. Why in the sense, uh, point on unit surface. This is the true factor because over here in x dash of n you will be getting only 4 samples, but in terms of your x of n you will be getting 6 samples. Okay, so that's what they're saying. So both are not equal. Okay. Okay. So this is the inference what we can get from it. Okay. So this is your example number 3. The next is example number 4. Next is example number 4. The given x of n equal to 1 comma minus 1 comma 2 comma minus 2. Okay. To find 4 point DFT. So if they're saying 4.2 point DFT means it is with respect to your number of samples in the unit circle which you have to sample. Okay. So for that, you have to find the Z transform of this. After that, you have to apply the Z value. Okay. So we'll be getting out and the solution will be moving on. Solution. So first you write the sequence x of n. They have given us, they have given it is 1 comma minus 1 comma 2 comma minus 2. So this part is 1. So here n value is equal to 4. Okay. So hence n is 4 means, so length of sequence is also 4. So now you write the general formula for DFT. The DFT formula you write. DFT formula is nothing but x of k will be equal to summation n equal to 0 to n minus 1. Okay. X of n, next is a triple factor. It's nothing but wn or nk. So this value, this, wn is nothing but a triple factor. So for wn, if you're writing expanding means you'll be getting n equal to 0, n minus 1, x of n e power minus j 2 pi by n, capital N. Okay. And here it is small n into k. So now we have to get the value of k. So k you already know. So 0, 1, 3. K will be equal to 0, 1 up to n minus 1. So it will be taking 0, 1, 2, and then n minus 1 is nothing but 3. Okay. So now we substitute the value for x of 0. First we have to find x of 0. Similar to the same DTFT concept what we have seen before. So x of 0 if you are putting means n equal to 0 to 3. So x of n, so n will be 0, right? Sorry, k will be 0. So you will be getting e power 0. So for this the value will be x of 0 plus x of 1 plus x of 2 plus x of 3. Okay. So you just refer this thing, the given sample, and you just add everything. So it will be 1 minus 1 plus 2 minus 2. So the value will be 0. So your x of 0 value will be equal to 0. Now you have to get with your x of 1. Okay. Then x of 1 value will be summation n equal to 0, okay, to 3. So x of n, okay, will be into e power minus the same thing. But the thing is that the n value will be putting, so it will be 1. So it will be putting 2 pi by 4. So this will be cancelled out and this becomes 2. Okay, into n. Okay, on solving this you'll be getting like this, x of 0. So you have to substitute these values. X of 0 plus x of 1 e power minus j pi by 2. Okay, plus x of 2 e power minus j into pi plus x of 3 e power minus j into 3 pi by 2. Okay, this is the concept. So now you have to put the value over here. So x of 0 value, it is nothing but 1 plus minus 1 into 0 minus j. Okay, 0 minus j is 2 into minus 1 minus j into 0. Okay, minus 2 into 0 plus j. Okay. So on solving will be getting minus 1 minus j. Okay, similarly you have to get with up to your x of 3. So will be moving to x of 2. X of 2 will be equal to summation n equal to 0 to 3 x of n e power minus j by n. Okay, this is the simplified part over here. So this thing we have to, so this thing you have to do, and will be x of 0 plus x of 1 e power minus j pi, okay, plus x of 2 e power minus j into 2 pi, again x of 3 e power minus j 3 pi. Okay, so now we substitute the value. You'll be getting 1 minus 1 into minus 1 minus j into 0 plus 2 into 1 minus j into 0 minus 2 into 1 minus, then minus 1 into minus 0 j. So you'll be getting the value as 6. Okay, on solving this, you'll be getting the value as 6. So this is x of 2. Now with respect to x of 3, the same thing you have to do. Summation n equal to 0 to 3 x of n. So on applying this, you'll be getting e power minus j. Pupil term will become like this: 3 pi by 2. That is the k value you are applying, right, into n. So this value becomes x of 0 with x of 1 e power minus j 3 pi by 2 plus x of 2 e power minus j 3 pi plus x of 3 e power minus j 9 pi by. On solving this, we'll be getting the value as 1 minus 1 0 plus j plus 2 into minus 1 minus 0 j minus 2 into 0 minus j. We'll be getting minus 1 plus j. So the final value is x of k equal to 0 comma minus 1 comma, sorry, not comma, minus 1 minus j, this is one term, comma 6 comma again minus 1 plus j. So this is what your final answer is. So this is how you have to find your DFT, and the next class will be doing the problem with respect to your ID.